Hello, this is just a quick video to do a couple example problems from homework number 6. So let's take a look at this problem right here. So the first thing that we notice is that it's a proportion problem. So we are going to use the process known as a one proportion z-test. Right. So basically, we're using the fact that any binomial distribution approximates a normal curve, where the middle is the mean is also n times p, and the standard deviation of this approximation is the square root of n times p times q, right? Therefore, if we're looking at the sampling distribution of this, then again, for the sampling distribution, the middle is going to be at n times p, is going to be a p hat, actually. Yeah, well, n times p is what you would expect based on your sampling size. And then this is the sampling standard deviation. It's going to be the square root of n times p, q times p divided by n. That's our standard estimate of the error. So let's just kind of work through this problem nice and slow and see how we're going. So it says, test the claim that the portion of men who own cats is larger than 90% at a significance of 0.05 level. So we're testing the claim that the portion of men, so we're looking for proportions, no mu's, there we go, is larger than 90%. So P is bigger than 90%. I like this one right here, no mu's. This one right here, okay? That's our claim. All right, so this is pointing to the right, so it's a right-tailed test. All right, based on a sample, 93% of 100 people, 93% own cats, so we are going to take, this is doing it by hand, and then I'll do it using the calculator as well. P hat minus what we expect it to be, 0.9, so p hat minus p. So our point estimate minus what we expect to get all over our standard estimate of the error, p times q times divided by n. So this is for our test statistic right here. It is going to be 0.93 minus 0.90 divided by the square root of 0.90 times 0.10, which is 1 minus q, 1 minus p, all over 100. So I calculate what that number is, and it gives me my test statistic. If you hold on 1 second, I'll do that on the calculator, talk you through it. So when you do this math, you end up with this equaling 1. Which means if you're on this curve here, you're 1 standard deviation away from where you expect it to be. And we are looking at a like a right-tailed test, so we want to know like how likely would this happen, or something more extreme to the right. Right? So this would be our p-value that we would be looking for, right? We look for 1 up to infinity of this value right here. This is our z-score, right? So if I wanted to find that by hand, I would use normal CDF to do it, but I could also do it pretty quickly and pretty easily using my calculator. So my TI 8489, I go to tests, I choose one prop z-test, and this is going to give me my z-test statistic and also my p-value. And in this case, that p-value is 0.15 ... like a bunch of other ones I can't remember, sorry. I keep having to flip back and forth from that to my calculator on my screen. So this is my p-value, this is my critical value, Now, I know that my p-value is not less than alpha, so I'm not going to reject. We're going to fail to reject the null hypothesis. We're going to say that the evidence suggests that the evidence does not suggest that it's different from 90%. The evidence does not suggest that it is larger than 90%. So now they asked about how to find this critical value. So this is a normal curve. The standard normal curve is 0, standard deviation is 1, and right tail, and we want 0.005 area right here. So when you're doing this, you're going to go onto your calculator, and you're going to go to distribution, and choose inverse normal because they gave me an area and they want a cutoff value right here. So when I do that, I go to inverse normal. All right, it asks for my area. Now, most of these, like with Minitab and with the calculator, most of them, they want the left tail when they're asking for area. So they want this area over here. And if this is 0.005, 1 minus that is 0.995. So for my area, I put 0.995, and my mean is 0, my standard deviation is 1. That's going to give me the number 2.57 as my critical value. Right. So this is 2.57. This is 1. You'll notice that my test statistic is not in my critical region. So again, we failed to reject. Hope that problem is helpful for you to see.